going to try this again. It completely derailed. Unit 3, Lesson 4, Reflections about the y-axis. A horizontal reflection is a reflection of the graph of a function over the y-axis. Last time we did x-axis, so it was flipping up and down. Now it's flipping left and right, okay? Results when the function y equals f of x is changed to y equals f of negative x. The reflection mirrors the original over the y-axis. All of the x values become their opposites, while all of the y values stay the same. So this is the exact opposite of what we did in the last lesson. X values are changing, y values are staying the same. Examining reflections over the y-axis in a table. So here we have our original formula, which is f of x is equal to x plus 2 squared, and our transformation, okay, f of negative x is equal to negative x plus 2 squared. So the only thing that changed here was the x. The negative is not on the outside of the parenthesis this time, it's just the x that changed, okay? So over here, all of our f of x values are the same, 0, 1, 4, 9, 16. It's the x values that change. So in our original formula, we have negative 2, negative 1, 0, 1, 2. In our changed formula, all of the signs switched. So we have positive 2, positive 1, 0, negative 1, negative 2. Okay, this should all be reasonably clicking based on what you learned about reflecting over the x-axis. The y values stay the same while the x values are negated. The point where the function intersects the y-axis stays the same in the reflected function. So the y-intercept stays the same for horizontal reflections. You can see this here. This point, the y-intercept, is the same in both of our graphs, okay? So this is our original. It got reflected over the y-axis, so it came over here. Our x values changed. Before we had negative 1, now we have positive 1. All of the y values stayed the same. So this is still 2 on both of them. This is still 1, 2, 3, 4, 5, 6, 7, 8. It's still 8 for y on both of them. But on one graph it's negative 1. On the other graph it's positive 1. Okay. Here's example number 1. Sketch the horizontal reflection of the function f of x is equal to 2x cubed to f of negative x is equal to 2 of negative x cubed. Okay, so only the x got changed to a negative, not the whole thing. So this is the original graph, and we're going to sketch the horizontal reflection. So it's reflecting over the y-axis, so it's going to be like this, and you can see that here. This blue line is the reflection. In the horizontal reflection, each point from the original function is reflected exactly the same distance from the y-axis, but it is now on the opposite side. So we have this point right here that's at right here. It looks like it's 1, 2, 3, 4, 5. We're going to say it's crossing right there, okay? So over here, it's going to be 1 away on the x-axis because it's 1 away on, I guess it's here. We'll say 6. Maybe 7. It's hard. This is little. Cut me some slack. Okay, so it's 7. It's 1 away on the x-axis, so we're going to go 1 in the opposite direction and put it on 7 on the y-axis, okay? We're just same distance, other side of the y-axis. This reflection over the y-axis is the reason the x values are negated or multiplied by negative 1. So every x value is just becoming its opposite, a negative of whatever that number is, okay? Here's example number 2. Given the table for f of x, create a table for the function h of x is equal to f of negative x. Okay, I'll show you how to do this with the math, but there is a simpler way. So I'll show you, like the logic behind it, and then I'll show you the simpler way to do it. So we have our, we don't have our formula. I can't show you the math. Never mind. It's really easy. And this is Han being like, I'm so sorry. You're so stupid. I know. It's hard to be me, but one of these days I'll get used to it. I did the wrong number. I did this like it was a reflection over the x-axis, and we need to do the reflection over the y-axis. It's not the f of x values that change, it's the x values that change. So it becomes negative 2, negative 4, negative 6, and negative 8. It's that easy. Okay, all we're doing is flipping the sign, positive or negative, on these values. And you can see that here. All of these values stay the same. We still have 1, 3, 7, 11. but the x values become -2, -4, -6, and -8. The function h of x is a horizontal reflection. Each input value will be the opposite of the original value, and the h of x values stay the same as the f of x values. Check in what happens to the x values and the y values of a function when it is reflected over the y-axis. This is the important point of the whole thing. This is what all of the questions are about. This is important. It should be in your notes. The x values become their opposites and the y values stay the same. Put this in your notes. Question number 1. This is all you. And here's Seungmin. Oh my gosh, I put Han as my panic. I screwed up and we're on Seungmin today. I told you we're derailing today. We're derailing really bad. Sketch the horizontal reflection of the function. Look, here goes my dog. She's upset because the garbage men are taking our trash. So we want the horizontal reflection of f of x is equal to -2x cubed plus 2 to f of -x equals -2 x cubed plus 2. Okay, so the easiest way to do this would be Algebra.com. But guess what? None of the quick checker practice questions ask you to graph anything. So we're just going to go ahead and show you. Boom. Okay, that's what it's going to look like. This is our original, and the reflection is the exact opposite. All of the y values stayed the same. All of the x values became their opposite sign. Here's question number 2, and there's our lovely Seungmin. The table represents the original function f of x is equal to 1/2 x cubed minus 4. Using the points from that table, create another table that represents the horizontal reflection f of -x is equal to 1/2 x cubed minus 4. Then plot the values from the two tables to sketch the original function and its horizontal reflection. So for this one, all you really need to do is create the other table, okay, that represents the horizontal reflection. So pause the video, do that, come back. Hey, I got the right guy this time. He's going to poke my eyes out because once again, I went to the wrong column on the graph. I'm still doing vertical reflections and we need to do horizontal. It's this one that needs to change. So this just becomes -x. This becomes +2, +1, -1, -2. That's it. That's all you had to do, okay? So this becomes 2, this becomes 1, this becomes 0, this becomes 1, this becomes 2. Now, if you want to see why this works, you would take this formula right here, plug in your f of x values, and solve. I'm not going to bother to do that. If you really want to see that, comment, and I will make a video showing that. Okay, so here's what your graph's going to look like. It's an exact mirror image. And if you look, we have one of these should be -x. You can see how well I'm doing. And look, they're the exact opposite. Ta-da! Here's a review. Horizontal reflections are reflections over the y-axis. X-axis, I can do this. Transform a given function, y equals f of x, to y equals f of -x. Reflect a given function horizontally. Horizontally is this way, side to side. Multiply each variable x in the function by -1. A horizontal reflection maps each point x, y to the point -xy. Put that last one in your notes. xy becomes -xy. Here's example 1. Describe the transformation of the function f of x is equal to x squared minus 2x plus 1 to fit f of -x. Okay, so it just wants us to describe it. So number 1, the new function is created by reflecting the original function over the y-axis. We're flipping it over the y-axis. The new function is the same distance from the y-axis. So this point is like halfway from 0. This one's like halfway from 0. You can do that with all of the points. Okay. Number 2, all of the y values stay the same while all of the x values become their opposite. Use the rule xy becomes -xy. The only numbers that change are the x's. And here is the table to show you. So f of x, which is the original one, which is the orange, these are all of the coordinate points that you have. And then for our translation, which is the blue one, you can see it goes from -29 to +29, -14 to 14, 0, 1, and 0, 1 stay the same because that's our y-intercept and it always stays the same. 1, 0 becomes -1, 0, 2, 1 becomes -2, 1. Check in what is the difference between a horizontal reflection and a vertical reflection. A horizontal reflection is a reflection over the y-axis. It goes side to side, where the y values stay the same and the x values become their opposites. X values change when you're going side to side. A vertical reflection is up and down. It's over the x-axis. The x values stay the same and the y values become their opposites. Example 2, describe the function transformation of f of x equals 2x cubed to f of negative x is equal to negative x cubed. Does the domain and range of this function change as a result of the transformation? So this I actually wrote wrong. This should still have the 2 here, okay, because it's the exact same. They, or actually this 2 shouldn't be here. That's what it is, okay. You can see from the formulas down here because it's exactly, they didn't shift at all. So it's the same formula with just one being a negative x. So we're going to describe this transformation. The function f of x is reflected over the y-axis. This horizontal reflection creates a mirror image of the function. The equation of the reflected image is f of negative x. In the reflected function, only the x-coordinates are changed. The y-coordinates remain the same. This is the same information for every single graph. So our original function is reflected over the y-axis. The x-coordinates change. The y ones stay the same. The domain and range of both functions is the set of all real numbers, because if you see, neither of them have a beginning or an end, okay? So they go both ways, all the way. However, the end behavior has been flipped as a result of the reflection. So, like, they're facing different directions. That's the only thing that changed, but the domain and range are the same for both of them. That's not on the quick check or the final of the domain and range, so don't worry about it. Example 3, identify the transformation on the graph where y equals f of negative x is a reflection of y equals x plus 2 squared. Select graph A or graph B. Describe one key function of the original quadratic function that changed after the reflection. So here is our original, the orange one. Which one is the horizontal reflection? Okay. Easy. We're not going up and down, we're going side to side, so it has to be A. Graph A is the horizontal reflection. The transformed function is reflected over the y-axis. This is the y-axis. And now mirrors the original function. The x-coordinates have changed to their opposites, while the y-coordinates have stayed the same. X changed, y stayed the same. Okay. The x-intercept and the vertex changed as a result of the reflection. So where it touches here, and the vertex, those are both the same in this problem. They changed, okay? The original function has an x-intercept of -2. The reflected graph has an x-intercept of +2. The x-intercepts in both graphs also represent the minimum value of the function, which is the vertex. Check in what happens to the x values in a horizontal reflection. What key features of a function may change as a result of a horizontal reflection? The x values change. They become the opposites, okay? The x values are multiplied by -1. Reflections over the x-axis may change the intercepts or the domain of a function, okay? Review. Horizontal transformations reflect a function over the y-axis. Horizontal y-axis. Thus, they transform a given function f of x to f of -x. This should definitely be in your notes, this whole spiel. To reflect a given function horizontally, multiply all x values by -1 while keeping y values the same. Okay? A horizontal transformation is the exact opposite of a vertical. Question 1, this one's all you. Write the equation of any parent function and a transformation of the parent function that represents a reflection over the y-axis. So an example, it could be any parent function, but they used y equals x cubed, and then its reflection over the y-axis would be y equals -x cubed. All you do is put a negative in front of the x in whatever parent function you used. Question 2, identify the transformation on the graph where y equals f of -x is a reflection of y equals 2x plus 3. Is it line A or line B? Explain your reasoning. This is our original. We're looking for a horizontal reflection over the y-axis. You need to determine which line is the correct one. And we know that the answer has to be B because they share the same y-intercept every time. Okay, Line B is the horizontal reflection. This line shows that each of the x values of the original function have been negated while the y values remain the same. A got shifted over to the side. We're not worrying about that. We're just worrying about a mirror image at this point. Here's practice question 1, very end of the lesson. Is the function f of x equal x cubed? Complete the table for its horizontal reflection. Now we have to do math. Okay, we have our formula, we have our x coordinates. So what we're going to do is we're going to change this to f of negative x. Okay, our x value is 0 equals 0 cubed. 0 times 0 times 0 is 0. There's our first answer. Easy enough, right? Let's do our next one. Our x value is 1 here. So f of, you can either put your x value here or just leave it negative x. It doesn't really matter. Our next x value is negative 1 cubed. You have to make sure that the negative stays in the parentheses because that's what we've got over here. Negative 1 times negative 1 is positive 1 times negative 1 is negative 1. There's your next value. Okay. Doop-a-doop. And here's our last one. F of negative x is equal to negative 2 cubed. Negative 2 times negative 2 is positive 4 times negative 2 is negative 8. There's your answer. It's that easy. Practice question number 2. Given the graph of the function f of x, complete the following table of the points for the horizontally reflected function f of negative x. Pause the video, do it, come back. Okay, so first of all, we need to figure out what our points are on here because we don't have the formula. Okay, so when x equals negative 1, f of x is going to be something. Okay, these are the ones that change. So on this graph, we're going to go to positive 1 and figure out, boop, it's right there. This one's going to be negative 2. Okay, and then when we have negative 2, that's going to be a positive 2. We have a 0. That's where it, because remember, these ones do not change. Okay, the y values stay the same for both of them. And I will show that this makes sense in just a second. So negative 3 becomes positive 3, and we go boop, and it comes right down here to negative 2 again. Now, you can double check and make sure this makes sense because you can go negative 1, negative 2, there's a point, negative 2, 0, negative 3, negative 2, and look at that, you've got your parabola that, you know, if I could draw to save my life would mirror that one. Okay, there's practice question 2. Practice question 3, graph the function f of x is equal to x plus 1 squared and the function of its horizontal reflection. What is the position of the point negative 4, 9 in the reflected function? Pause the video, figure it out, come back. Okay. Work smarter, not harder, people. You don't have to do anything super complicated here. We know that one of these changes and one of these stays the same. It's the x that changes, so this is just 4, 9. You don't have to put any more effort into it than that. Practice question number 4. If the point 3, negative 5 is on the graph of f of x, what point must be on the graph of f of negative x? Don't overthink it. The only thing that changes is the x coordinate, so it has to be negative 3 and 5. Don't just pick number 3, they shuffle these answers. You have to find the right numbers. Practice question number 5. Given the graph of f of x is equal to the square root of x minus 1 plus 1, which of the options is the graph of f of x? So here is our original problem, okay? Which one is the horizontal reflection? Because that's all we're doing. It shouldn't be hard. We're not flipping up and down, we're flipping side to side. So it has to be option 1. Okay, they may have these labeled differently on your graph, but it's the one that's to the side. Here's quick check. I will not tell you the answer, but I will tell you how to find it. The original graph of the function y equals f of x is shown. Select the table that represents y equals f of negative x. So first you need to figure out your points on here. And then you need to figure out which points are going to change. So we have negative 2 right there. We have negative 1, and those are the only clean ones, okay? So this point right here is negative 3, 2. I will tell you this much. Negative 3, 2. This is our original. Okay. Our next one is negative 2, 0. And our last one is negative 1, 2. Okay. One of these sets, either the x or the y changes and the other one stays the same. Figure out which table is the correct one. Quick check question 2. If the function f of x is equal to x plus 1 squared is reflected horizontally, how does the reflection of point affect the point negative 2, 1? One of these points is going to change. One is going to stay the same. Find the right answer. Slow down. These quick checks can affect your grade over time. Quick check number 3. Choose the correct statement to describe a true relationship between any point on f of x and f is f of negative x. These are all the same questions over and over, just worded differently. Which statement is true? Okay, this is the one that's asking you, if you have xy, then in a horizontal translation, what are you going to end up with? Okay, every time. Which one changes? Don't overthink it. Quick check question 3. Given the graph, actually I think this is 4. Yeah, it's 4. Given the graph of f of x is equal to x plus 1, which option is the graph of f of negative x? This is our original, this orange line. Which one is its horizontal translation? Okay. Remember, they share something. Quick check question number 5. If the point 13, negative 7 is on the graph of f of x, what point must be on the graph of f of negative x? One of these numbers is going to change. Which one is it? It's really easy to find good Xiangmin pictures. Like, I'm really, really picky about what ones I put on here because I know I'm not going to get very much eye candy, unless I keep screwing up, which is a very real possibility. But his, it was just like the first few ones. It was just boom, 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 boom. So if he's your bias, I understand why. Bye, guys.